Good morning and welcome to Lab 7. Here we go.
Looking at our steps per revolution, we have 2 times the number of phases times the number of poles. There are 2 phases and 4 pairs of poles, or 8 poles. 2 times 2 times 8 is 32 steps per revolution of the motor. And then we have a 64:1 gear ratio. So 64 times 32 equals 48 steps per revolution of the actual output shaft.
So we just finished wiring our circuit. It's a little bit complicated in here, but you can see those red wires on the left connecting to Arduino plus 5 volts. Pins 9, 10, 11, and 12 are taken care of. We have our motor orange, yellow, pink, and blue. Our pink is actually white because we don't have a pink wire. And then we have our external power supply connected to pin 8 on our H bridge. All our grounds are connected to the Arduino ground. And then we have our stepper motor itself. I attached a little plastic tie on it so we can see the direction of motion much more easily. So my Arduino code has 2 functions, one called clockwise spin and one called counterclockwise spin. They each take in a degree value and then a delay value which correlates to the speed. Taking a look at the clockwise spin function, we run a for loop. Each for loop has 4 different steps in it. If we want a full 360-degree rotation, we would do 512 of these for loops or 2048 steps. You can see the high and low combinations in a specific order. This corresponds to what we need to make our H-bridge run the correct direction. Our delay speed is the delay in between each of these steps. So a higher delay actually corresponds to a slower rotation because we're delaying the steps. And then our counterclockwise spin is the exact same thing, except our order of our steps is reversed. So here, high, low, high is first, but in our other function, high, low, high was last. So I'm about to show the stepper motor in action. One thing I found is that the delay value should be between 2 and 15 milliseconds. Below 2, the stepper motor doesn't work properly, and above 15, the stepper motor is annoyingly slow. Okay, so we're going to spin our stepper motor clockwise at 100 degrees at a fast pace, delay of 2. Then we're going to spin it clockwise 90 degrees at a slow pace, delay of 5. 180 degrees counterclockwise fast, delay of 2. And 90 degrees counterclockwise, delay of 5. And then we're going to repeat. All right, so looking at this in action, fast clockwise, slow clockwise, fast counterclockwise, and slow counterclockwise. And those angles are exactly what we want. So that was that 100 degrees, 90 degrees, 180 degrees back the other way, and then another 90 degrees counterclockwise. For this second part, we're going to move at very specific increments. So we're going clockwise 45, clockwise 90, clockwise 180, clockwise 360, then counterclock 45, 90, 180, and 360. We're doing this with a delay of 2 milliseconds between each step, so at a pretty fast pace. Let's see it in action. So 45, 90, 180, and then here's 360 all the way around. And let's do reverse. So 45 counterclock, 90 counterclock, 180 counterclock should go all the way around, and then 360 counterclock right back to where it started. Nice. And that is all for Lab 7. Thank you for watching.